Today in Algebra 2, we are on section 4.1, brand new chapter. And this chapter is all about functions and the Cartesian plane. Now we've done some work with this in previous math classes, so this first section is kind of a review, a lot of things we've already covered. Let me adjust my camera here. So we are on the intro to two variable linear equations. So two variable, meaning we're going to have two unknowns, usually x and a y. Linear, meaning it's going to be a straight line if you were to actually graph the function. We're not dealing with anything curvy. We're also not going to have any exponents, no x squareds or cubes. These are just going to be directly x to the first power, y to the first power, okay? We're starting off with the familiar formula. A squared plus b squared equals c squared. That should sound familiar. We know that is the Pythagorean theorem. We know this is used to identify the missing sides of a right triangle. So if we had one side was A and this is B, we know C is your hypotenuse. We're going to be looking at some equations today that are derived from this Pythagorean theorem. The first one is the distance formula, and I'm on page 154 in your textbook. So we're going to list in your notes each formula. And the distance formula says D equals the square root of parenthesis x1 minus, sorry, you're using 2 first, sorry, this book uses 2, x2 minus x1, close the parenthesis, square the parenthesis, plus y2 minus y1, close the parenthesis, and square it. All of this is underneath the radical, okay? So it doesn't look much like this formula, but your textbook does a great job of breaking down and kind of showing you on the next page how this formula, distance formula, relates to our Pythagorean theorem, okay? That we're talking about finding the distance between 2 points. Like if we were trying to measure from this point here to this point here. But we know on our graph, we only have the squares. We really can't count across the squares if it goes diagonal. So using, the distance left and right compared to our distance up and down, our x values and our y values, we're able to come up with our distance formula. And it's based, again, if we were trying to solve for c squared, we'd have to take the square root of both sides. That's where this formula comes from. Now, we're talking about distance, so even though it's a square root, our answers are going to always be positive because our distances are always positive. So we're going to ignore the plus or minus when we're talking about distances with our square root. All right? Let's look at the midpoint formula. So we're going to get all the formulas down first. And then if I can fit it on this video, the examples will be on here. If not, the examples will be on another video. That'll be right behind this one. Midpoint formula says capital M equals, nice big parenthesis here, we're going to need x1 plus x2 over 2. So it's a fraction, okay? You're adding your x values and then dividing it by 2. We're making an ordered pair here. There's a comma in the middle. So this is one part of the ordered pair. The second piece is going to be your y1 plus y2 over 2, and then close the parentheses. So this is showing us how we'll find the first number of our ordered pair and the second number of the ordered pair. So you'd have to have 2 points to use this, okay? So you'd have to know the ordered pair for this beginning point and the ordered pair for the ending point, and then you could plug those values in to find the middle. So you remember from geometry, midpoint meaning the middle. So if we're talking about these 2 points, we want to know what's the very middle of those 2 points. It would be easy if it were just on the x or the y, but when it's diagonal, not so much. We need a formula to help us out. And this formula does it. It says, hey, it's going to be halfway between your x's and halfway between your y's, or the average, which is why we are adding them together and dividing by 2. We're finding the average of each of these distances. All right, and last formula should be very familiar. It's the slope formula, okay? And the slope formula, I apologize, my marker is kind of dying a slow death. I hope you can still see it. This formula is on page 156 in your textbook if you can't see it very well on the board. And we know slope is the lowercase m, it's a symbol for that, and we are taking the difference in our y values, y2 minus y1, over the difference in our x values, x2 minus x1. The slope, if you recall, is telling us the steepness of our line. So once you've got 2 points, we want to know how steep is that line that's drawn between those 2 points, and we do that by comparing the distance, the difference between your y values over the difference in your x values. A lot of times your slope will be a fractional value. Remember, it can be a positive or a negative number depending on the direction of your line. And we're going to look at some of those lines here in just a minute. So for all of these formulas so far, you're going to be given 2 ordered pairs. And let me just kind of put that in your notes here too, that you're going to be given ordered pairs. And an ordered pair basically looks like, you know, your 2 points, you've got your x value, and you've got a y value, alphabetical order. They're going to give you 2 of these, okay? And we'll call the first one that we see, we'll consider those to be your x1 and your y1. The second point, or ordered pair, we'll call the x2 and y2. So when they give you these points, assume x1, y1, x2, y2, and then you can plug in the values into these formulas. Instead of having to go back through the whole Pythagorean theorem and solving it ourselves, we're going to shortcut and use the formulas that are given to us, okay? So plug in the values to find these 3 things when given your ordered pairs. The last thing on page 157, let's talk about slopes and what they look like. Let me erase some space here. So first, we'll take a look at what a positive slope looks like. So here's our Cartesian plane. We know the x values are left, right, the y values are up and down. If we have a graph or a linear equation, I'm looking for a different color. If we have a linear equation that when we graph it, it goes increasing from left to right, okay? So as you start from here and work over to the left, we see the trend is going up. This is considered to be a positive slope, okay? Now, if we have, instead of positive, a negative slope, for a negative slope, kind of the opposite of what we just showed. Sorry, it's not quite the same size. As you go from left to right, so I think I said it wrong this way, left to right. Left to right on this one, if it's negative, you'll see that it's going down. So starting from the left, going to the right, it's trending downward. That's a negative slope, okay? So even though they have arrows on both ends, it's left to right. What's happening left to right. We can also have what's called a zero slope, or like no slope at all. I like to think about skiing, that if you have a zero slope, then it is completely flat, that there's no skiing really happening. You're kind of just walking if it has a zero slope, so it's flat. And it can be anywhere on this graph, it just needs to be straight across, flat. The last one is an undefined slope, and it's going to be the opposite of your zero slope. If it's undefined, it is so steep that you can't really identify how exactly how steep it is, because it just goes straight up and down, okay? So for this one, instead of going across, it goes straight up and down. And again, it could be anywhere on this graph, it just needs to be up and down, okay? So you'll have some questions that ask you just to identify what type of slope, just by looking at the graph. Is it positive, negative, zero, or undefined? All right, so like I said, if there's, for the examples of these, there'll be another video. If not, this information should be a quick review to give you enough information to work the assignment for today.